Topic 8, volumes of prisms. 8.1, area, quadrilaterals. The area of a parallelogram is base times perpendicular height. Now this is something that we would have looked at in previous years, and the reason for that is if we had a parallelogram, what we can do is we could cut a shape or cut a perpendicular through that. We could trace this red shape out and we can move it to the edge there, and what we have is that if we had removed the left hand red part and we move it to the right hand side, we're left with this shape here, which is a rectangle, and the base length is the same as the original parallelogram and the height is the perpendicular height. So then we've got base times perpendicular height, and that works out the area of a parallelogram. So this first example, we've got a height of 5 millimeters and a base of 14 millimeters. So area is base times perpendicular height, which is 14 times 5, which is 70 square millimeters. The area of a trapezium. So a trapezium is any four-sided shape which has one pair of parallel sides, and the area is a half of A plus B times H, where A and B are the parallel sides and H is a perpendicular distance between them. So find the area of the trapezium below. What we can see is that the 8 and the 6, those sides are parallel, and the 5 is perpendicular to those two sides. So the formula, A equals a half of A plus B times H, which is a half of 8 plus 6 times 5. So 8 plus 6 is 14, and a half of 14 is 7. So it's 7 times 5, which is going to be 35 centimeters squared. Kites then, so the area of a kite is a half of the product of its diagonals. So let's try and make that a bit clearer. If we've got a kite, its diagonals are the vertical and the horizontal line. So the vertical could be diagonal 1 and the width could be diagonal 2. And product means multiply, so the area is going to be a half times D1 times D2. So what we've got in this example, we've got the height of this top triangle of the kite is 7 centimeters, and the bottom triangle has a depth of 11, and each part of the horizontal is 8 centimeters. So that's what that diagram is showing there. So what we've got is area equals a half of the diagonals, the product of the diagonals. So that's going to be a half times, now the first diagonal is 11 plus 7, so that's 18. So it's a half of 18 times, and then the horizontal diagonal of the kite is 8 plus 8, which is 16. So it's a half of 18 times 16. So 18 times 16 is 288, and a half of that is 144, and that's squared centimeters. A rhombus has 4 equal sides and its diagonals bisect each other at 90 degrees. To find the area of a rhombus, whether use the formula for a kite or a parallelogram, depending on the information we have available. So let's draw a rhombus and see what we mean by that. So all 4 sides are equal. So if we knew the base length and the perpendicular height, because a rhombus is a special type of parallelogram, then we could do A equals base times perpendicular height. But because a rhombus also fits the properties of a kite, if we knew the length of the two diagonals, then the area could be a half of D1 times D2. So depending on what the information you have would determine what we're going to do for that, or which formula we're going to use. So find the area of the rhombuses below. What we're going to have then is one rhombus whose four sides are all 5 centimeters. And it has a perpendicular height of 3. So this is one where we'll use area is base times perpendicular height. The base is 5 and the perpendicular height is 3. So that's going to be 15 square units. So let's assume they were in centimeters and do 15 squared centimeters. The next example then, we'll look at the following rhombus. So the first diagonal was 16 and the other diagonal was side 6. So the area is going to be a half times diagonal 1 times diagonal 2, which is a half of 16 times 6, which is 48. And again, do centimeters squared. Composite shape is, or a compound shape, is made up of a number of different polygons or shapes, and it would be necessary to split it up into its constituent parts to find the total area. So in these examples, we've got an L shape and an irregular pentagon. For the first one, the L shape, what we can do is we could make a number of different add on a couple of different lines to make it in 2 different shapes. So the first option would to do a horizontal line, or what we could do is we could draw a vertical line to have 2 different rectangles. There is a third option that we could use, and that would be to work out the large rectangle and then take away the area of the small one. So there's many different ways in which we can do this. So I'm just going to start off with the one that I had picked initially. So this is going to be 1 and 2. So it's best to try and figure out what the dimensions are. So the bottom rectangle we can see is 4 wide and 2 tall. The first rectangle though, we're not quite sure what the dimensions are straight away, but we can work it out. We know the height is, this height is 5, and we know the height of the bottom rectangle is 2. So if this is 5 tall and the bottom part makes up 2, then the height of the smaller rectangle is going to be 3 centimeters tall. For the width of one, we've got the base length is 4 and this part is 3. So this extra bit on the first triangle or rectangle must be 1 centimeter. So area of 1 is going to be 3 times 1, which is 3 squared centimeters. The second one is 4 times 2, so that's 8 square centimeters, which means the total area is 11 squared centimeters. For shape 2, or the irregular pentagon, which we can see is clearly made up of a rectangle and a triangle. So 1 and 2. For shape 1, the area is a half times the base times the perpendicular height, which is a half times now the base length of the triangle. Because this is a rectangle, BE will have the same length as CD, so that's going to be 20. So it's a half of 20 times by the perpendicular height, which we can see is 10, and that works out to be 100 squared centimeters. The area of the second one is a rectangle, so area is base times height, which is 20 times 15, which is 300 squared centimeters, which means that the total area is going to be 400 squared centimeters.